My dear unemployed friends, welcome everybody. In today's video, we are going to implement a sparse matrix abstract class with two different approaches, with two different implementations. I've done most of the work by now, but I still miss one more implementation. I would have preferred to do a live coding session with a live stream, but YouTube doesn't allow live streams before applying for a permission that lasts 24 hours. And yes, I'm doing this video in English because I have to learn how to speak better English and with more confidence. Uh, because like yesterday I was told that I was very bad at tutoring, and yeah, anyway, no one is going to watch this video. So we start with the actual code that is better. What I've done, so I started with doing everything in my main.c++ um, code without using any module. So here I defined my class sparse matrix COO, and I have defined I have defined all different stuff, mandatory stuff like the constructor, the public constructors, and so on. But in the end, I've put everything in a .h++ header in a header file where I have an abstract class because it has all virtual pure virtual methods, virtual like this one, get rows number, get course number, get size. Also, this is a pure virtual method, and I've set n rows and calls as protected, so that I can initialize the number of rows and calls in the children class, like the inherited class, like a sparse matrix COO, that is the first implementation. I've used some dumb, I've implemented some dumb methods like this get element, that is not what I was, that is, yes, a dummy get element. It's very basic get element method, but in the end I overridden the operator, like the call operator, instead of the assignment operator, like, because if I had done this, I would have required like a proxy, like another class with um, a proxy class, like a proxy row class, and with these I would have to return like uh, another class that is a row, and in the row class define another operator with the square brackets. And I found this very not as intuitive as using the call operator. and this works just as fine. And yes, and the last thing I've done with a bit of trouble was to templatize the class. I said with a little bit of trouble because in the beginning I defined these methods like the definition of the call operator and the call operator for assignment. I have defined them in the in a C++ in a CPP file that I'm not using anymore. I could just remove it. I can do this because templates basically you can't define um, methods of a templatized classes outside the HPP file substantially. I mean, maybe there's a method to do it, but all the sources also official FAQs say that it's very likely to have linker error. In fact, yes, it or it shows all the errors that I've been these are all the errors that I received when I first compiled with distinct definition and declaration files. 7 minutes of 7 minutes of like introduction I've already gone, and I wasn't going to do a video that was longer than 10 minutes. So is it better if I stop here and publish another video where I do actually implement the other algorithm to store sparse matrices, which is compressed sparse row format, CSR format. This format employs again three arrays to represent A, an array values containing all the non-zero values, of length the number of non-zeros, an array columns of integers containing their column indices of the same size as the of the values array, and an array row index of integers with the cumulative number of non-zero entries up to the ith row excluded. The length of such array is the number of rows plus 1. By convention, we assume that a row of row index of 0 is equal to 0. Very difficult to understand, and when I'm done, I think I'll record another short video. And for today, for now, it is everything. And thank you for watching my video. Also, thank me to recording this video because I don't think anybody else will see this video. It is just an exercise for me to exercise English speaking and presentation and explanation. I hope you enjoyed the video. Thank you. Bye.